All right, let's just solve this. I'm going to show you two different ways to do this, okay? The first way is using, I don't know, kind of the stuff I taught you. The second way will be seat of the pants, okay? So we heat the wave and change the wave speed from 321 to 351, right? We're not going to change the length of the pipe, but we are going to change the speed of the waves there, right? So the fundamental looks like this. Okay, that's a quarter wavelength, right? So we go 0.622 is 1/4 wavelength. I'm trying to draw like a quarter wavelength in a pipe there. I know I failed, but imagine that's what I actually drew there, right? So my wavelength is 2.488. Okay, I just multiply that by 4, and that's what I get. Okay, and then I can just find the frequency. The frequency is V divided by wavelength, and this comes from the formula V is F lambda. Okay, which incidentally in your data packet looks like C is F lambda. And I refuse to use the IB notation because it's stupid. All right, so here we go. So we go, but now instead of using 321, we're going to use 351, right? Divided by 2.488. So 351 divided by 2.488 is 141.1, right? So the new frequency is 141 hertz. And that's my answer, right? Okay. So if you're paying attention, you'll notice that we did this calculation in the first part of the first problem of this, right? That did not change. All that changed was the numerator of this, right? So if 321 gave us 129, then 351, the new velocity, is going to give us something that's proportionally higher, okay? So if you're paying attention, the frequency is proportional to the velocity. Increasing the velocity increases the frequency, and that's because the wave can pass us with more frequency because it's going faster, right? So another way to do this, right? This is seat of the pants. Seat o pants. Is just set up a proportion, right? You knew from the previous problem that it was 129 hertz, right? So 129 is to 321 as x is to 351. Just do proportions, right? Okay, so x is going to be 129 times, just use this ratio, 351 to 321. That's all we change, right? You can do this with the ideal gas law too, it's my favorite. 129 times 351 divided by 321. And indeed, I get 141. I'm slightly off because I rounded this answer. That's a slightly rounded answer, but there it is. I encourage you to do that, right? And in all these problems, the next two questions, we just tweak something about it, right? In some of these, right? So if we change the velocity, if the velocity gets faster, the frequency will get higher. Use the ratio of the velocities to make the actual frequency higher, okay? There you go. That's all I've got to say about that.